Hey guys, this is Professor Abood coming to you live from Madrid, and this week we are going to talk about wastewater treatment. So, as you all know, wastewater is essentially what goes into the sewer, and so you know what comes from your household that goes into the sewer. But in addition to that, a lot of the water runoff that goes into the sewer, on the streets when it rains, all of that will go to a wastewater treatment facility. And so I'd like you guys all to read through some of these processes of water purification. But essentially, what we're going to do this week, I've tried to draw it out a little bit, is you're going to obtain a little test tube that contains barium nitrate, polluted with clay and sand, and you're going to shake that well. So this is kind of what your test tube is going to have in it. And as step 2, you're going to let it settle. So after we let it settle, most of the sand will come out as a solid. The third step will be to add some iron chloride. And so when we add iron chloride, well, I'll show you guys what's going to happen. So what's going to happen is that iron chloride is going to grab onto this clay up here. So you see the irons disappear from here, and they grab onto the clay, and they're going to fall out as well as solids. So then you're going to essentially separate the solids from the liquids using a centrifuge. And it's important to remember that the centrifuge must be balanced on both sides. This is kind of what your centrifuge will look like from the top, and this is kind of what it will look like from the side. So when you place your test tubes on there, it's going to spin really, really fast. So what you want it to do is to make sure that the other side is balanced with about an equal amount of liquid, so that your centrifuge isn't off balance, it doesn't end up flying off the table. So we've added, just to recap really quickly, we added, we have our test tube with all these three guys in it. The sand will fall out after we let it settle for a little while. We add iron chloride. The iron reacts, well, will grab onto the clay, and we're still left with some iron. But now that this is in a suspended form, that but it's kind of solid, we're going to be able to centrifuge it and separate the solids from the liquids. So the solid iron and clay will go to the bottom, and we'll be left with this. And so here I put a little note of our solids. We're left with mostly iron chloride, a lot of chloride, and barium nitrate. And we want to get rid of this barium and of this iron. So what we're going to do is we're going to add hydroxide, and that's going to precipitate that iron. So here we see that iron running away with all these three hydroxides, because it's got a 3+, and each one of these have a -1 charge. But we're going to add excess hydroxide. So after this iron hydroxide turns into a solid, we're going to probably, let's see, where is that? We're probably going to separate it again. And you're going to measure its pH to see how many extra hydroxides you have. After that, we're going to add sulfuric acid. And the reason for that is twofold. The hydrogens, the extra hydrogen ions, will grab onto the hydroxides and turn into water, essentially. So OH plus hydrogen ions is going to become water. And your sulfates will also dissolve. But what's really important is that the barium sulfates grab onto each other, because see, you've got a 2+ and 2-, so that they grab onto each other and turn into a solid so that you can easily separate it. So you're essentially going to then just be left with your barium sulfate in solid form, some chlorides, some sulfates, some hydrogen ions. Well, now we've got to neutralize these hydrogens, and I think that is step 6 here. Add sodium hydroxide to adjust the pH to as close as possible to 7. So we add sodium hydroxide, and the hydroxides will react with the hydrogens, and the sodiums will just be left floating around. So the hydrogen here, we see it reacting with hydroxide to turn into water, and what we're left with is your nitrates, your sulfates, your sodium, and your chloride. And so essentially the whole process is to remove this barium, remove the sand, and remove the clay. And so it's a fairly simple procedure that we did. But so let's just very quickly go over it again. So we start off with these three guys. The sand precipitates out after a little bit of time. It just kind of falls out because it's a solid. We add iron chloride. The iron will grab onto some of the clay. The clay then falls out as a solid. We centrifuge it to get rid of these solids. we're left with a little bit of iron, a little bit of barium, and some ions. So then we add hydroxide to precipitate the ion. The ion is, since it's a 3+, will grab onto these hydroxides. You add excess hydroxides, the solids will fall out, or you'll separate them, or centrifuge them if need be, and you're left with hydroxides. And so these hydroxides will then have to be neutralized, and the barium will have to be, we have to all still get rid of the barium. So we add some sulfuric acid, the sulfate group will grab onto the barium, and the hydrogens will grab onto the hydroxides, and that will pretty much yield you water, and your nitrates, your chlorides, your hydrogens, and your solids that will fall out. And then you want to try to neutralize it to about a pH of 7, and you're left with just these ions over here. So these ions should be pretty much drinking water. So hopefully that kind of introduces this week's lab. And if you guys have any questions, let me know, and I'll see you soon. Bye-bye.